and quartic polynomials. A cubic polynomial, the highest degree of x is x to the third power, and a quartic polynomial, the highest degree of x is x to the fourth power. And what we're going to do in this lesson is we are going to learn how to factor these types of polynomials. The first thing you need to look after when you're factoring a cubic polynomial is to check for a common factor. In this case, the common factor is 2x. So what we're going to do with that is we are going to factor it out. We're going to pull it to the front. So we have 2x parentheses x squared plus 5x plus 6. We can further factor the inside by finding the numbers that multiply give us 6 and add together give us positive 5. Those two numbers are 2 and 3, so our final factored form is 2x times x plus 2 times x plus 3. In the next example, we have 3x cubed minus 3x squared minus 36x. A common factor for this polynomial is 3x. So after we factor out the common factor, we are left with x squared minus x minus 12 inside the parentheses, and 3x is on the outside of the parentheses. You can further factor the quadratic inside the parentheses into x minus 4 and x plus 3. So our final answer here is 3x parentheses x minus 4 times x plus 3. There's a shortcut for factoring the sum and difference of perfects cubed. The first thing you need to do is you need to write down the list of perfect cubes. 1, 8, 27, 64, 125, 216, 343, 512, and 729. You're going to need to be able to recognize these numbers when they show up in a polynomial. The pattern for factoring the difference of perfects cubes is the following. Whenever we have the difference, so a cubed minus b cubed, you can use the following pattern to factor the polynomial. A minus b, parentheses, times a squared plus a times b plus b squared. This first example, we have 8x cubed minus 1. The first thing you need to do is you need to recognize that 8x cubed is the same thing as 2x raised to the third power. So our a value is going to be 2x, and our b value is just going to be 1. So anywhere you see an a, you're going to plug in 2x, and anywhere you see a b, you are going to plug in 1. So we have 2x minus 1, parentheses, 4x squared plus 2x plus 1. You have to be very careful with the a squared term because you need to square both the 2 and the x to get 4x squared. There's a pattern for a sum of perfect cubes. For a sum of perfect cubes, if we have a cubed plus b cubed, we can break it down into factored form of a plus b times a squared minus a times b plus b squared. Notice how the signs have flip-flopped in this situation. In this example, we have 27x cubed plus 125. First thing we have is the 27 is the same thing as 3 raised to the third power, and 125 is the same thing as 5 raised to the third power. So anywhere we see an a, we're going to plug in 3x. Anywhere we see a b, we're going to plug in 5. 3x plus 5, parentheses, 9x squared minus 15x. The negative 15x comes from 3x times 5 plus 25. And again, don't forget to square the 3 for your a squared term. What I want you to do is I want you to pause the video and see if you can try to use the sum and difference of perfect cubes to factor these two polynomials. Once you're done, hit play again to see if your answer is correct. For the first problem, we have a equals x and b equals 6. We're using the sum of perfect cubes because we start with a plus sign. So we have x plus 6 parentheses x squared minus 6x plus 36. For the second example, a is going to be 4x, b is going to be 10. We use the difference of perfect cubes because we're starting with a minus sign. For x minus 10, 16x squared plus 40x. The 40 comes from 4 times 10. The 16 comes from 4 squared plus 100. Be very careful of the sign. So first thing you need to check is that you have the same signs in the first set of parentheses that you do in your original problem. And that you have opposite signs here. And your final term should always be positive because we're squaring it. Quartic polynomials, again, that's ones with the fourth power. If they are trinomials, so that's 3 terms, and all of the terms are even degrees, so that's x to the fourth, x squared, and the last one's a constant. You're just going to factor it like you do a regular quadratic, but you use x squareds instead of x's. So just like with quadratics, we ask ourselves what numbers multiply to 36 and add together to give us negative 13. The answer here is 9 and 4. Both of them need to be negative. These quadratics can be factored even further because they are the difference of perfect squares, so we can break down the factors even further into x minus 3 and x plus 3, x minus 2 and x plus 2. In our final example, we have 2x to the fourth plus 3x squared minus 5. We can factor this to be 2x squared plus 5 and x squared minus 1. 2x squared plus 5 can't be factored any further, but x squared minus 1 can, so the final factored form of this one is 2x squared plus 5, parentheses x minus 1, parentheses x plus 1.